Okie dokie, and we meet once again. This is video number 7 of our Move Smart Contract language tutorial. In this video tutorial, we are finally starting to work with vectors. Let's not waste any more time and let's get straight to it. Let's move. When we work with vectors, we are working with arrays, lists, or collections of values. I can define a vector with a type U64. Every single element inside this vector is going to be type U64. And this will look something like this. All the values stored inside the vector are U64, type unsigned integer 64. Any type can be defined as a vector type. I can say vector, and I can define this to be address. This will be type address. So every value that is stored inside this vector will be type address, meaning that this will be 0x12, then we'll have another address which will be x144. You get the idea. Address is stored inside the vector. When we work with vectors, we can manipulate that data a little bit better. We can run functions to execute a loop and do something with the values inside that vector. We could also use a vector to store a struct type. I'm going to show you right now. I'm going to say that I am going to define this to be a struct type. So let's call this property. So when we work this particular struct, we are saying that we want to store struct property. Let me expand this real quick. And all the type abilities. So we can say has store, drop, copy. And I can define this to be bed, U64, bath, U64, okay? And so forth. Let's do that. So if I define a vector with type property, I am saying that every value that is stored inside this vector will entail everything inside of it. This particular object, which is the struct, will be stored inside this vector. Property 1, then property 2, property 3, okay? So inside this property 1, we'll have those values. Inside property 2, we'll have different values, and property 3, and so forth. With the vector, then I can use this type, so then I can work with the data that is inside. I can loop through the data, I can borrow the data, I can read the data. There's a lot of utility behind the vector type. So let's go ahead and build the module, and let's use most of the functions that we have available on the vector, or at least the principal functions. As you know me, let's call this vector1, and let's start. So I'm going to say module, and let's call this vector1. We're going to say use std, and from there we are going to invoke vector. I am going to create a function that is going to show you all the actions that we can call against the vector. I'm going to say vector basics. Okay, let's begin writing and describing each one. Okay, so the first thing for me is to create a vector. Let's call this a list. We're going to be defining a list, which will be a vector type. So we're going to say equals vector, and we will call empty. And what type of vector am I going to be initializing? It's going to be U64. We're just going to store numbers on this list. Okay, I'm going to add a comment, initialize a vector. Next, let's add values to that vector. One way that I can add values to the vector is by just pushing back. Insert 10, number 10, at the end of the vector, okay? AKA the last index. So let's do that. Let's call vector. From the module vector, we will invoke push underscore back, because I am going to be manipulating the values inside the vector. Is going to be mutable. So I have to define this to be a mutable reference to what? To list, which we initialize, right? So we're going to say list. Awesome. And the value, 10. That's how we add a value to the end of the vector. And this value should reflect this. Let's add another value. Let me just add another one. So I want to say here, but in this case, it's going to be 20. So now we have 10, we have 20. Okay, awesome. Now let's store a value, but specifying a particular index. Okay, so the index is the position inside the vector where I need to store that value. But hear me out. If the value that I'm passing as the index does not exist, meaning that the vector doesn't have that index, it's going to fail. I'm going to add this comment here. We're going to store number 30 at specify index number 2. Okay, vector. And now we are going to insert mutable. Again, we are modifying the state of the vector, and we are going to call list. And now I got to pass index value, which will be 2. And now I can pass the actual value, which is 30. If you print this vector now, it's going to look like this. Okay, so it's going to be index 2. We got 0, 1, and 2. I'm going to take the opportunity to add more. I'm going to add 3 more lines here. Let's just add this and add another one. So at index number 3, we want to add 50. we got 0, 1, and 2, which is 30. Now it's going to look something like this. It's going to say 10, 20, 30, and 50. Let's use 2. Well, let's change the value to 20. Okay, so I'm going to say now what's going to happen is number 2 is currently at 30. So 30 will be pushed to number 4, and then 20 will take its position. I'm going to say 10, 20, and now 20 will take over 30's index, and 30 will be pushed to number 4. Okay, and 50. Awesome. Now another functionality that I can do with a vector, I can swap one index with another, so that effectively moves the value from one index to the other. Let's say I want to swap index 0 with 1. So index 0 is valued at 10, index 2 is valued at 20. So let's do this. Vector, boom. We're going to say swap, and again, it's mutable, making changes, passing list, and I want to swap 1 on 0. So once we do that, what was stored in index 1, which is 20, will be replaced with 10 and vice versa. The vector now should look like this, should look like 20, 10, 20, 30, and 50. Next, let's start grabbing values out of that vector. Let's grab one value, and let's increment the value and store it back. We're going to say, let's return the vector index 2 as a mutable reference value. Okay, I am going to be returning the index number 2 as a mutable reference value, which means I can update the value. So in this case, if I'm talking about index number 2, we're talking about this particular value, which is 20. I'm going to say let value, and it's going to be equals to vector, and we are borrowing. Okay, so we're going to say borrow mute, and what we are passing mutable reference to list, which is our vector, and we pass index number 2. Okay, this will, like I mentioned, is going to return 20. Returns and stores in value 20. Now, next, what I'm going to do, I am going to increment that by 10. I'm going to say value is equal to value plus 10, okay, which will give us 30. Now I want to pass 30 onto the vector. I'm going to copy it. And what I'm going to be passing is value. Okay, so we're going to replace this with value. Okay, this will be stored in the existing vector, and the values inside should be 20, 10, now 30, because we have taken effectively that index, 30, 20, now it's been pushed to index number 4, and again 30 and 50. There we go. Next, let's remove an item from the vector. I'm going to say remove element from vector at index 3. Vector remove, pass the mutable state, mute list, index number 3. After I do that, I'm effectively updating the vector to look like this: 20, 10, and effectively I remove value number 20. Okay, so that means that I'm going to still leave 30, no longer 20, 30, and 50. So now we should remain with this value. We have removed 20 out of the vector. I can obtain the last value inside the vector and remove that value from the vector. 50, I can grab the value out of the vector and remove it, but also use the value for something. Return last element from vector, which will be the last index, and remove it, okay, which is very different. So now I'm going to define this vector and the function pop underscore back. Obviously, we pass the mutable state to list, and that should be it, right? So once we do that, we effectively end up with this array, which is 20, 10, 30, and 30, and it has returned 50. Okay, so which means that I can do this. I can say let value, and value will be 50. So I can obtain that return. Okay, but we're not doing it. Let's go ahead and return the vector because we're going to be testing. Okay, so let's do list. If I do list, I can return it. I just have to make sure that I'm going to tell that we are effectively having a return here. The return is going to be vector u64. That will be the type. Okay, beautiful. So we effectively return, and we should obtain list. If everything goes well, if we print this vector, it's going to show this. It's going to show this right here. Let's go. Let's give it a shot. Let's build a test function, attribute test, and let's call this function test function. Let list, and we're going to say equals to vector underscore basics. And I want to print. I'm going to say test only, use std debug print, but check this out. I can do as p, so I can do an alias out of print. All I have to invoke down here is going to be p. So I can send p reference to list. Let's give it a shot and see how that goes. You know, here aptos move test Crossing fingers. I forgot to invoke this to be the function. Okay, so under empty, I forgot to add this. Okay, just make sure that when you initialize the vector with empty, we initialize as a function. So I gotta do that. Control S, and let's see. Boom! Awesome. What do we see? We see 20, 10, 30, and 30. Beautiful. Let's continue. Now that I know that I obtained that value, and this is the value exactly what we're getting, now I want to do the following. Tell me if a value is present inside the vector. We know that this list will return this. This should give us this value. What I'm going to do is I'm going to say vector contains, okay, again, mutable reference to list, and I want to check if inside this vector we have the number 10 stored as one of the elements. Okay, so I'm gonna say reference to number 10. Once we run this, we should obtain a true. Okay, and this is how we can search inside the vector for values. Next, I can put a description here. Return true if vector contains 10. In this case, it's going to contain 10, which is true. Now there's a similar function that is index of. Confirm if a value is present, return us the Boolean result of true if it's present, and also the index of that value. Where is it located inside the vector? Let me just call this returns true and the location of a value. The index, I should say. So now let's say vector, boom, index of. We're going to pass this to be mutable, and we are going to say list. And let's say that I want to obtain the index where number 30 is located. And here's the thing, we have two number 30s stored. Well, index of is going to return the first instance. We're going to say list, and we're going to pass the reference to number 30. When you run this, you should obtain two values. You should obtain the result, which is a Boolean, in this case will be true, and the index of the first instance of 30. The first one is going to be 0, 1, 2, okay? So those two values should be returned when we call index of. Awesome. Next, let's work with loops. Okay, how do we read each value and do something with each value? By calling a loop. Let me define the loop here. So I'm going to say another function up here, and this function is going to be called while loop. So I'm going to say function while loop vector. Okay, and the argument that is expected is list. We have to pass that argument, and this we type vector u64. Okay, and let's just return it back because we want to keep using it. So I want to say vector u64. If we don't return it, we won't obtain this. I have to define what's the total length of that vector. I can say return total vector length. And now I'm going to define this to be let length equals to vector length. That's it. And I passed the reference to list. Now we are going to initialize, we're going to declare I, which will be the increment in the loop. So I'm going to say I equals 0. Now we write that while loop. Okay, so we're going to say if I is less than length, then continue executing. Okay, boom. Now we are going to grab value. We want to print value. So then we can print every single item inside the vector element. So I'm going to say value equals what? We are going to be borrowing vector borrow. We pass list. It's not mutable because we're just going to read. We're not going to write to it. List. And what do I need to pass? I need to pass the index. Okay, in this case will be I because it's going to continue incrementing. It's going to be I. Okay, next we want to print value. Okay, so I'm going to say P and value. Boom. And don't forget, we got to increment I. Okay, it's going to be I is equal to I times 1. And that is the loop, the while loop. We're passing I and we're incrementing I right here. And as long as this matches, then it's just going to continue with each value. Okay. And we want to return list. Beautiful, because we want to still use list for something else. Okay. I need to define P. So I'm just going to remove it here. And now we're just going to do it globally. Boom. Go over here, add it here, save it, and let's invoke it. So I'm going to say let list equals while loop vector, and I'm going to pass the list. And the list is going to be list. Awesome. And if everything goes well, we should see those values being printed out. Okay, so let's give it a shot. Hopefully my syntax works. And it did work. Awesome. From first attempt. Okay, so you can see that it started printing all the values individually. Awesome. So we know that the while loop works and it's able to iterate from the vector. Okay, so this is the while loop right here. And we have defined it here. Now I want to do a for each. For each is another function that we can use to do something with each value inside the vector, similar to the while loop. Okay, so with that said, I'm going to create a function first to do the following. There's two types of for each. There's the mutable and immutable. Mutable allows us to modify the values inside the vector. Let's write a function called for each vector. Okay, we will pass the same, copy, pass it here. We don't need to return it. I think this will be the end. Okay, and now let's work with the first one. The first one is just going to invoke a for each, and it's going to return me the closure. What is happening on the back, it's another loop, but all we are going to obtain and return is each closure with each value inside the vector. Check this out. For each, and I gotta pass list, which will be the list or the vector. And now check this out. I get to do a closure. This is very common in Rust, in which I can define a closure and I can say list. So by doing this right here, I am effectively obtaining whatever value it's been accessed or has been returned when the for each is running on the back. That for each, it's a loop that is running inside this function, and we are just grabbing the values as they're being passed over that loop. And inside this closure, I can now say, invoke a function that I can pass this as an argument, okay? This will not be the vector at this moment. This is not the vector. This will be each individual value. So now, with that said, I want to do a function that is just going to print every value, okay? So I can say function read element, okay? So each element will be stored here, and we can pass it one by one, okay? And what it's the type that I'm expecting. It's going to be U64. It's going to be what's inside. I deconstructed the vector. I just removed the vector and I'm just grabbing every value individually. Okay, so I can say element here. I'm going to say U64, right? What I'm going to do, I'm going to print P, and I'm going to pass reference to element. That's it. That's all we are doing. We're printing. Okay, so now I can grab this function, copy, I'm going to pass it right here. You can see that I'm combining the closure and the function, and we are going to pass list. Okay, this will be the individual value obtained from the for each passed onto this function, which is going to print those values out. I'm going to save this, right? And let's see how that goes. Okay, let me save it here. For each vector, let's pass list and see how that goes. Beautiful. So we have dual outputs because the while loop is still running. This is the while loop right here, and this is the for each. So it basically passed the first index, the value, pass it to read element, print it out the second and third and fourth. This is great. Now I want to not only read and print, but I want to update the value by incrementing it by 1, for example. For that, I need to do the following. On this for each vector, now I'm going to do this. I'm going to say vector for each. Now it's going to be mutable. Reference mutable to list, because we're going to be making changes. And the rest is going to be similar, but we have to do another function. And instead of reading it, it's going to update it. So instead of read, we're going to say update. Let's do that function right here. I'm just going to copy this and we are done. Okay, so we are still passing the element, but now I want to increment that element. Let's just declare a value here, and this will be, let's dereference element, right, times 1, and we want to print value instead of element. That's it. And if everything goes well, oh, I got to change this. Update element. Beautiful. Everything goes well, we also should obtain the new values. And as a matter of fact, I can do this. Let me do a print so then we know which function has been executed. Okay, so I can say P, U referenced UTF-8, B, and this will be for each. So we know when we see the output, we know that it's the for each and then the for each mutable. And it's going to be very obvious because the for each mutable is going to have an increment by 1. But I just want to do it this way. Okay. And the while loop. Okay. So I can say here, before it hits the for each, we are going to say print or P, same thing. We're just going to do this. I'm going to say while loop. Okay. And now we should see all of the values. Awesome. Let me go back and give it a shot one more time. And we have a problem. Oh, I see what it is. Okay. I forgot something. That's the problem when you copy and paste. So with update element, this value, it's mutable, which means that I have to declare the type to be mutable. That should do it. Let's see now. Unbound variable. Oh, I haven't declared this. I am going to bring that UTF-8, which I haven't done. So I'm going to add it here. Use std string, and I'm going to say UTF-8, right? And let's see if we are better now. Okay, now we only have this issue. So it's for each. Did I change this to be mutable? I think not. I think did not. Okay, so remember, for each, mute. Try it one more time. It should be done. Awesome. Okay, so we have the while loop right here. We got the for each and for each mutable, and we were able to update the state. okay, each value. Awesome, that's it. Alrighty, we have finished video number 7. On video number 8, we will continue working with vectors. Now let's work with vectors by storing data on a vector and referencing structs as property. Let's go ahead and let's do this.